Yes, welcome again to this lesson. And in the previous lesson, we talked about cations, and we said they are positively charged ions, and they are formed when atoms, metal atoms specifically, lose electrons. We also said that it is formed by metal atoms, although hydrogen, which is a non-metal atom, can form a cation. And also ammonium ion is not a metal ion. Okay? Now we want to illustrate how cations are formed by using an example of lithium. So the question is, how is lithium ion formed? It has a charge of +1. How is it formed? To understand or to know which kind of ion is formed by an element, you must know either the group number, the group in which that element belongs in the periodic table, or its atomic number. Now we have the full symbol of lithium here, which is capital L and lowercase I. On the top left-hand corner, we have 7. This 7 represents atomic mass. So always when you see the symbol of an element, the figure on the top left-hand corner is representing atomic mass. Then this now represents atomic number. Now atomic number is now 3, right? Atomic number is 3. But atomic number is the same as the number of protons in that atom. So the number of protons in that atom is 3. So previously we said that the number of protons in a neutral atom is equals to the number of electrons. So if that is true and lithium is a neutral atom, then the number of electrons in that lithium must be equal to the number of protons, which is 3. So the number of electrons is actually what? 3. Okay? So if you want to find the number of neutrons, then you will remember that atomic mass is equal to the number of protons plus the number of neutrons. So if you want to find this number of neutrons, then we make it the subject. So we subtract the number of protons from atomic mass. And what is the atomic mass? Is 7, which is this. And the number of protons is 3. So 7 minus 3, we get 4. The number of neutrons is 4 in the lithium atom. So the electron configuration is 2 to 1. Where have we got this from? We know that the number of electrons is 3. So the arrangement of those electrons, we have 2 in the outermost shell, in the first energy level, then 1 in the outermost shell. So the question is this lithium atom stable or not? This lithium atom is not satisfied. It is not full. Why? Because it has only 1 electron in the outermost energy level, which is the second energy level. It should be having 8 for us to say it is full. So it is not stable. It is looking for a way of becoming stable. So what happens now? Let's try to illustrate this in terms of an atom. So if we are to illustrate a lithium atom, how many protons did we say a lithium atom has? We said it has 3 protons. So these are protons. I'm going to put 3, and they are found in the nucleus. So I'm putting them in the nucleus at the center. 3. Okay? Then how many electrons should it be having? They are also 3 electrons because they are the same. Okay? So I'm going to put electrons. These are the electrons. And where are they found? In energy levels. So I'm going to put 1 there, and the second one there, and now the third one in the last energy level. So this is a lithium atom, and we are told that this lithium atom is neutral. Why? Because the number of protons is equal to the number of electrons. Okay? Now, how many neutrons did we say are in this lithium atom? We said that there are 4 neutrons. So I'm going to put these are neutrons. 1, 2, 3, and 4. Now, I want you to notice something. The number of protons is 3, the number of neutrons is 4, and the number of electrons is 3. Now, let's look at the net charge on that atom. The net charge on that atom is 0. Why? Because the number of protons which are positively charged is 1, 2, 3. The number of negative charges 1, 2, 3. So they cancel, and the atom is having a 0 charge. So it is a neutral atom. And what is its atomic mass? The atomic mass, which is also the mass number, is 7. Good? Great. Now, let's look at, supposing this atom is going to lose 1 electron to become stable, because it has electronic configuration 2 to 1. So it becomes stable by losing 1 electron. Supposing it loses this 1 electron, I'm going to pick out this 1 electron and put it there. So it is now remaining with 2 electrons. You can notice that the number of positive charges is 3. 1, 2, 3. The number of negative charges is only now 2. So the total charge on that atom is now a positive 1 charge. Why? Because of this extra positive charge. So that atom is no longer a usual atom. Now we give it a special name, which is a positively charged ion, which we called a cation. So how are we going to write the symbol of this ion? Let's go and try to write the symbol. Now, remember that we said there are 4 protons, rather there are 4 neutrons in the nucleus. Those are 4. And how many protons? 3. 1, 2, 3. And how many electrons were there in the neutral atom? There were 3. 1, 2, and the last one, 3. So this is a neutral atom. Supposing we remove 1 electron to make this lithium atom stable. Let me remove it and you see. Or let me first return and we look at the symbol of the element. The symbol of the element is this. When it is neutral, it has a charge of 0. But let me remove this electron and we see. When I remove that electron, the symbol of the element changes. It now has a charge of positive 1. It has a charge of positive 1. Because of that positive charge, it is now a positively charged ion. Now, in our usual examinations, we don't write this 1. We just write a positive charge to represent positive 1. If there are 2 positive charges, then you can say positive 2. Okay? But since this is only 1 positive charge, we just write a positive charge. Okay? Great. So that is how the symbol of the element will change. It now will carry a positive 1 charge there. But we don't write the 1. It is a silent figure. So in the next lesson, we shall look at yet another example of how a cation is formed. Thank you for listening.